I'm pleased now to introduce Bhautik Joshi. Bhautik is a senior research engineer at Canva in Sydney, and he sits somewhere at the crossroads of art, science, engineering, film, machine learning. What else am I missing? It's all sorts of things. He has worked with global technology and creative giants like Industrial Light and Magic, Flickr, Adobe, and most recently Canva. As an engineer, he leverages his skills across broad and deep real-time data analysis at web scale, stereoscopy tools for feature films, motion capture, virtual, augmented, extended realities, previsualization for TV, game development, real-time computing, signal analysis, surgical simulation, and medical imaging. So not much. Yeah. And we here at RMIT are also thrilled to have Bhautik sit on our industry advisory committee for the media programs. So without further ado, Bhautik.
Alrighty. Slides, please, folks. There we go. Amazing. Okay. Pickup's good. Okay, I'm just going to stand over here. Hello, everyone. So thank you, Dan, for the wonderful intro. So I think just in addition to sort of like the, I guess, a little bit of my history here, I've been looking at my general thing really is, and I'll just maybe just get straight into it, right? So my thing here is that, yeah, I work at Canva, and I come from a family of toolmakers, right? Like, we're technicians. That's what we do. And in particular, my own particular flavor of tool making has been around building tools for creative people, right? So for people who want to do creative expression, it doesn't matter whether they're pros or whether they're amateurs. The general flavor of work that I've been looking at is like how to sort of really, I guess, enhance and magnify the work that people are doing. And especially when it comes to sort of being able to do this expression in the digital domain. And so, I was very lucky to sort of, like, 3 years ago, I ended up working at Canva. And Canva's sort of like, big mission is to sort of enable everyone to design. It's a bit of a cheesy tagline, but it really is true. And our goal here is kind of an interesting one, right? So, my own particular history, like I said, is, been working for some of the big places. So, I was at ILM for a while. It was at, it was Lucasfilm. I was at Adobe. I was at a couple of other places. And, all of these were catering to sort of really like high-end creative professionals. And the thought here was that when it comes to digital tooling, these tools have a lot of controls. They have a lot of, ability to sort of like really sort of like fine tune what you're doing. But the hypothesis at Canva was that, could we take some of this really complex tooling and make it a lot simpler, a lot more accessible to use, right? So can we come up with sensible defaults? Can we find a way of really enabling folks to sort of be expressive, but without necessarily confronting them with a lot of controls? And that happened at the same time as, I guess, if you like, the rise of generative AI, which is an interesting story. It actually goes back a lot longer than most people realize. And that has really given us an opportunity to see sort of like, can we build new tooling to help people be creative and expressive, but perhaps cut out some of the drudge work, right? So really sort of like, the central theme through all of this is like, what can we do to sort of enhance people's creativity, but not take away the human element of it, right? So this is more about helping people magnify their expression rather than create it. So, the really sort of like, and if we were to sort of come up with like a provocation for what I was going to talk about, the theory here is can we make AI boring again, right? As Dan pointed out, it's been going since 1956, right? So, and there are many periods where, we've had these many AI winters where it's sort of become boring and ordinary, but I don't necessarily think that's a bad thing, right? I think AI, if we do our jobs right, if we, in terms of like, okay, so when I say we, I mean, I'm talking about people who are building creative tools. For folks who are building creative tools, if we build it the right way, hopefully you won't even notice that it's there. This just becomes an invisible part of your workflow, right? So nobody talks about sort of pixel compositing or the speed of GPUs or any of that anymore. It's just kind of there in the background, right? And these tools have gone a long way to sort of really enhancing creativity. We don't talk about how it's made anymore. We're just talking about the actual creative expression that you want to be able to do. So I think Maybe just to sort of like set some framing here, right? There's two things I think that are interesting to think about. First of all, if you think about sort of text to image models, there's definitely a piece of framing here that I feel like it's less true nowadays, but perhaps even 6 months ago, it was still very faulty, right? And there was this idea, frankly, when it comes down to it, is that AI models are omnipotent, right? Which means that you can feed in any text prompt, and what it will be able to do is that it will be able to infer what you've told it, and it'll be able to generate anything, right? So it's able to sort of understand anything and generate anything. And it's just simply not true, right? Models are finite. They're not godlike, right? They're not omnipotent. So it's interesting just to note that these models do have limits, right? And, in many ways, it's like playing a game that is like, one of those infinite world games, and you come to the edge of the map, right? This is a way, like, you're running around and you find the edges of what you're, we're at the stage now where we're starting to run into the edges of the map. We're starting to run into the limits of what these models are able to do, and that's okay, right? But given that new framing, it allows us to sort of perhaps address this work a little bit more with a realistic framing. Another thing is that astonishing is not the same as good, right? And that this is a frequent thing that we use in-house, right? When we're thinking about new innovations, when we're thinking about the latest AI development that's coming along, just because it's astonishing doesn't necessarily mean that it's good, right? I think we see this with every year with sort of new developments in rendering in film or new developments with AI models, right? Like when you see the new press release, you go, well, this is astonishing. That doesn't necessarily mean that it's productive or it's good, right? When I say good, I mean useful, right? So that's another sort of there's another, we're not trying to be jaundiced here, but we're trying to be realistic about what these things are rather than sort of being carried along by the hype train. So given that AI is just a tool, right? What can we do that we can what are the things that we could do to really sort of tell the computer how we feel, right? Like in terms of how we feel or what we want, what can we do to better control what these models do, right? Because again, we've got this idea that we can be able to tell them anything, but what if we, instead of words or a coarse mechanism like that, what if we had other ways of telling the computer this is what I want that are a little bit more straightforward, right? That are a little bit more familiar. So again, just setting up the talk a little bit, right? A lot of this has just got to do with, I guess, our evolution through that path. So there are two phases when it comes to doing when it works with AI tools, right? We're talking about inspiration, right? So thanks to the talk this morning from Leonardo, right? The workshop from this morning from Leonardo, we were talking about, using these models for inspiration, right? You're using it to sort of get started, to sort of create that idea, that the place that you're going to start from, right? And they're very, very, very good at this. But there's this second phase, which we're in particular a little bit more interested in, which is iteration, right? So there's versions of these tools where what you do is you use them to iterate on the content that you have. You use them to edit it. So rather than create things from scratch, you're talking about what can I do to, again, magnify and enhance what I have. So early work on this, this one actually goes back to 2016. And we did some early experiments. This was back when I was working a completely different gig, on style transfer, right? I don't know whether you folks remember that was a thing. That was sort of like a mid to late 2010s thing. And we tried this experiment where I tried this. We were one of the first groups to try this with video, right? So the idea being that, we could take a video frame and then combine it with some sort of inspiration for the style and turn it into a picture, right? And the idea is that it, it redraws it in the style of this particular picture. Again, like I said, this stuff has been around for absolutely ages. And we tried some early experiments with this, and we actually got approached by a director in LA, which was shocking. And she asked us, look, I've done this, I've got this short film that I'm making, and I have this painting that I've done. Can you redraw the frames in this movie in the style of this painting? And we were like, sure. Right. This technology was brand new. We were full of hubris, and we thought this was going to be very, very, very simple and very, very, very easy. Right. So, this is going to be a weekend project. You just send me the movie frames. We'll run them through the machine, and we'll generate a movie out the other end. And we were really wrong. We were so wrong that we actually wrote a paper about how wrong we were. And it was an interesting clue into sort of this early ML tooling, the current generation of ML tooling, that control is critical. Right, this assumption that what you can do is that you can just simply take in the movie frames and give them a style image and everything is just going to work. Just the assumption simply wasn't true, because when we worked with the director, she was just constantly coming back, can you make it look a little bit more like this? And it's kind of like, well, not really. It's kind of the algorithm's going to do what it's going to do. I don't really have the control. So we ended up having to sort of pick this apart and end up like putting new handles on this tooling. So we were actually able to impart a certain degree of control on the result, right? So there's this assumption that, it's just going to do the work is simply not true, right? You need to have like the human hand in this, your intention. You need some way of signaling your intention through the process. So, we boiled this down to sort of like three principles when it comes to sort of building AI tooling, right? They've got to be directable, which means that you've got to steer them in a particular direction. They need to be, so as in like, they need to do what you tell it to do, right? However you tell it to do it. It needs to be iterable, which means that small changes in the input lead to small changes in the output. And it has to be precise, right? So it needs to do exactly what you tell it to do. So over the next few slides, I'm just going to go over sort of like our experimentations with doing this really over the past sort of like maybe 12 to 14 months. So the first thing that we did, this was from a while ago. So this is a particular product that we have called Magic Media. So I guess if you like, it is a competitor of Leonardo a bit. And this is just basically the idea that what you can do is that you can put in words and generate an image, right? So, if you ask it to generate a horse on a beach, it will give you a horse on a beach. It's very horsey. They generally have the right number of legs. If they have extra legs, that's okay because more is more. And, it looks nice. There's lovely reflections. It's very convincing. But where it starts breaking down, and this is less true now, but like it was a little bit, it was a little bit of a problem earlier on in the year. If you ask it to sort of do something very specific, it tends to sort of break down pretty quickly, especially if you ask it to do something that involves some sort of compositional control, right? If you want to control the composition in the picture, these models, they take hints, right? But they won't, if you say, I want you to move this cube over a few pixels over to this particular direction, it won't do it. Like they don't offer that degree of control, right? And they certainly have problems with sort of like sometimes comprehending logic, and they have trouble like understanding composition. And part of it is because language is also somewhat ambiguous, especially English language is somewhat ambiguous, right? So this ambiguity leads to sort of like ambiguous generations as well, right? So you got all sorts of combination of red, blue, left, right, cube, right? So we looked at this and we thought, okay, right, can we perhaps do something a little bit better? So we started looking at techniques that we could take this as a starting point and start adding degrees of control. So, was this directable? Sure, right? You can give it an idea of what you want, but was it iterable? Absolutely not, right? Small change in the prompt leads to a small change, like a very large change in the output, and it definitely wasn't precise. So we did this thing, like I said, a little over a year ago called Magic Morph. And the idea was that you're able to sort of take a shape and then restyle it based on a prompt, right? So we've got this text over here on the left, and then we were able to make it look like balloons or vegetables or wood carvings. And I guess the innovation here, for lack of a better word, was that we're able to do this and have it sort of draw outside of the lines a little bit, right? So rather than sort of making it strictly stick to the shape that was there, we allowed it to get a little bit blobby, right? So if your shapes were a little bit rounded, if they're a little bit spiky, it was able to sort of generate that sort of that expressiveness without compromising on, say, transparency, right? So the idea is that you've created this object and you want the areas that are transparent to stay transparent, but then if you've got, for example, like lines and shapes inside the object, it should kind of work. And it's all right. It's not amazing, but it's okay, right? And sometimes it can be a little bit horrifying, right? So you've got this little sugar glider that turns into a vegetable, and you've got those terrifying vegetable eyes. Hey, look, it's AI weirdness, right? But it was an experiment here where we were trying to give it some degree of spatial control, right? And this was a little bit of a hint on the way to sort of like where we really wanted to go. And the way this particular, I mean, for those of you who have any sort of like technical interest, the way that we did this was that we used this thing called control net, right? So the control nets are a way of injecting spatial guidance, right? So it's saying like, I want this particular, I want you to use this shape to influence the result. But we added some sort of like custom algorithms here to have it so that, again, like I said, we can preserve the transparency. So the idea is that like you've got a particular shape, we convert it into an image, we run it through the pipeline, and then in that pipeline we'll get an output at the end, like I said, that maintains transparency, right? So this is very much sort of speaking to sort of our graphic design customers and folks who wanted to do graphic design, but they wanted to have a little bit more expressiveness, or they wanted to restyle the shapes that they already had. So was it directable? Sure. Was it iterable? Not really. Again, small changes in the prompt led to small changes, like very large changes in the output. But was it precise? Maybe, right? It was starting to get there, right? In terms of like having it follow a shape and create exactly what you want. So our clue out of all of this was that prompts can be difficult, right? When it comes to sort of like expressing exactly what you want, because it does require you to be loquacious. It does require you to sort of like have a knowledge of like to a certain degree, you need to sort of like know a little bit about what are the prompts that are going to give you the best results. And again, like I said, this talk was from, some of these slides are from like even just like 6 months ago, where they're starting to date a little bit. There are techniques now where you can take sort of like relatively simple prompts and you can enrich them using GPT, but still they map to sort of this special code words that are there inside the model that aren't really English anymore, right? These map to sort of like visual concepts. And these concepts are used to sort of drive the results, highlighted by the talks this morning. So, in the same way that like, talking to a paintbrush is kind of a weird interaction. Like our thought here was that, what could we do to sort of try to remove prompting from the equation, right? So if you wanted to do sort of like, image operations, so forget image generation for a second, you want to work with pictures, what could we do to sort of perhaps remove prompting from the equation altogether so that we're working with images in a more of a naturalistic way? So the cue that we took here was from computer vision, right? So if you look at the history of generative AI, right? So going back sort of more like 20 years, it came out of robotics. And it came out of this field where what we would do is we were just building self-driving things, right? So you wanted like a delivery robot or you wanted a car to drive around. And what it would do is that it would take multiple inputs, right? So it wasn't just a camera that you'd stick on the front. You'd have a variety of sensors that would be used to sort of sense the world around it. And this would all get fed into a model that would have, I guess if you like, sort of like some people call it multimodal, but they've got this very rich sense of what the world looks like, right? So not only will it give an idea of like, it will look at a picture and go, okay, something is this particular color, but it will also go, it's maybe this far away. It's from this particular perspective. It's got some idea of what's going on. So the intuition here was that that these models themselves, right, these text-to-image models, because they do come from this history of computer vision, they've got this deep buried knowledge about the world. And that sounds kind of strange, right? But it's like, there was this experiment that got done in the mid-2010s where folks were training these computer vision models for robots that were navigating around. And these robots would have multiple sensors, right? So they'd have like an ultrasonic sensor to figure out how far things were away. They'd have like stereo cameras on them so they're able to sense depth, right? Sometimes they'd have radar on them. So what happens is that all of these inputs would get fed into the model and it would get trained with a fusion of all of this information. Now, what became really interesting was that if you took that same model, right, and you took away all the other inputs and you drove it with just a camera alone, it was able to sort of sense the world around it just using the camera information better than a model that was trained with just the camera alone. So the idea is that all of that extra information would get buried inside the model. It had this intuition about what the depth was, even though it didn't have any depth information, for example, right? So, our hunch here was that these models would have a buried idea of what the world looks like. Like some people, like, OpenAI have referred to this as kind of like world simulation, whatever you want to call it, right? There is this intuition that is inside these models for sort of like what does the whole world look like, right? So we tried this with this tool that we built called Magic Expand. Again, sorry for the namings. They're a little, our product folks like giving these things whimsical names. It's kind of cool, right? But anyway, so what we've got here is an example of our outpainting tool. And again, this is from a little while ago. We've gotten a bit better since then. But what we've got is that we've got our source image here on the left. And if you look on the left here, you've got that little kick of light that is on the left-hand side, right? So you've got some, and if you look at, for example, like on the ground, you've got shadow directions. And when we ran it through our tool to do outpainting, again, this is some slightly custom code that we have. What it's able to do is that it's able to infer that there's a light source on the left. And very reliably, it will generate something like, it will generate a light source on the left, usually a set of windows, right? When it does the continuation on the right-hand side, it will, for example, generate shadows that are going in the right, in the correct direction, right? So what it's able to do is that it's able to infer, it's able to, for example, like come up with a pretty good idea of like what the perspective is going to be for a picture that gets expanded, right? So our hunch here was that these models have this very, very deep very intuitive idea of, like I said, what the rest of the world looks like, right? It's able to situate these pictures, right? So whether that's for in-painting or out-painting jobs, because it's got this strong intuition of what it's, what we're able to do with it. So that's where things got really interesting, right? So again, just for folks who have maybe got some sort of technical interest here, again, this was very much sort of very strongly based on that control net pipeline, right? Where what we're doing is that, again, we're using some information about the shape, but then we've got extra layers here that also like help it. I guess we give it a hint, right, about what we think the result is going to be. And the idea is that we combine hints from multiple sources to end up with a result that is much more plausible than other techniques, right? So was this directable? No, you kind of get what you get. Was it iterable? Absolutely not, right? But was it precise? Yes, right? And that was really, really interesting, right? This is the first technique that we built that were able to give us results that were pretty precise nearly all of the time, right? Nearly all the things that we run to expand come up with pretty plausible expansions rather than, for example, just putting like a picture frame around things. So the thing that we got to just recently, so this is something that we launched a few weeks ago called Image Blend. This was a long piece of research. This took about 6 months to do. And our hypothesis here was that we could use that intuition about pictures to combine things together, right? And the idea is that what we want to be able to do is that we want to be able to, like, there's this common operation that happens, right, where a common job that you need to get done, where what you want to do is that you want to be able to drop an object into a picture, and when you put that object into the picture, you want to make it convincingly look like it was there. And some people call this photo bashing or whatever, but the idea is that you want to be able to combine this, and it's a very labor-intensive task. It takes you many hours. You've got to like maybe relight the object that's there. You want to keep the shape, but you want to sort of like make it look like it's there the whole time. And frankly, it's hard to do, right? This is like an hours long process. So the tool that we built does that pretty quickly all on its own, right? So what it will do is that it takes the object, it will reinterpret it. It interpreted that there was a light kick behind it. So if you look on the light on the left-hand side, it's sort of casting the shadow in the right direction. It's put the bear on the table, right? So like it's made sure that there's good sort of contact there. It's rendered a shadow underneath it. It's rendered some reflections in the wood. It does a reasonably good job. And the shocking thing about this is that all of this is, largely speaking, automated, right? There's very little hinting that we have to give it to sort of generate a good result. There is obviously some secret sauce that we've got to do to sort of like really tune the results. But largely speaking, this is the model doing most of the lifting, right? And this is based on sort of like custom code that we wrote. So again, this is where we're starting to sort of diverge pretty strongly from sort of like, the image generation pipelines. We're using the information that's in the models, but we're interpreting them in a completely different way, right, to be able to do these tasks, right? So, same example, just to show it's not a magic trick, right? So we've got this very imperfect cutout of Neil Armstrong on the moon. You can see a bit of his foot is missing. You can see that, like, the cutout is very rough around the edges, and the lighting does not match at all, right? So when we relight it, it does a much better job of sort of trying to match that backlighting. It's not completely perfect. The lighting should be completely inverted from like left to right, but we're getting there. It's got the light between his legs. It's figured out like reasonably good ground contact between him and the table. It's even completed the rest of his foot, right? So the tools that we're building, like I said, are just built around this, and it gets weird, right? So this is where this really gets pretty strange. So there's when you allow it to sort of get a little bit more interpretive, right? It will also do things where when you combine things together, it will combine them in very sort of like unusual and unexpected ways, right? So we've got this helicopter that is occluding the boat. And if we let it run in its most interpretive mode, you get the heli boat. And it's weirdly plausible, right? It's not sensical, right? That's a different thing. It doesn't make sense. But is it plausible? Is it visually plausible? Yes, right? Like it's got the shadows right. It's blended the helicopter into the boat. As a visually plausible result, this is the thing that we could do, right? And I think what we've stumbled on here, I hope, is that it's a little bit of a plausibility engine, right? And what it will do is it combines things together into a plausible way. Whether it's sensical or not, that's up to the user. It's up to you, right? It's up to you in terms of like the compositions that you put together. But then what it will do is that it'll take any two things that you have, and it will try to combine them together, like I said, in kind of a plausible way. So again, just talking a little bit about how we've done this. Again, this very much sort of is based around sort of giving it a hint around shape. So we feed in our shape hints, and then this gets run through. So for example, like when we put this car into this scene, what it's done is that it's reinterpreted the perspective on the car. So it's no longer the original car, right? But we've allowed it to sort of change a little bit. So it changes the perspective a little bit, and it renders the shadow, but it also adjusts the perspective so it matches the perspective of the background thing. And there's an interesting tension here, right? There's a tension between like there's a tension between like having the original object in the image and then reinterpreting it so that it is a little bit more like it lives there, right? So like the example that we're talking about over lunchtime, let's just say you've got like a family photo and you've got a picture of your dog, right? And what you want to do is that you want to put your dog into the scene. In the most faithful version of it, we can put the dog into the scene, and what it will do is that it will relight the dog, right? But the perspective might not match. It still looks like it doesn't fit because it's still like, the perspective is warped. It doesn't match the picture behind it. In the most interpretive mode, what it will do is that it will fit the dog into it. It will reinterpret the perspective. It'll really look like the dog looks like it's meant to be there, but it's no longer your dog, right? And there's a really interesting sort of tension between, basically adding more noise, adding a little bit more sort of interpretiveness to it and having it fit versus going with the original object, but perhaps not matching the perspective. So another, just another sort of like sets of examples here. With this one here, what we're going to do is we want to blend these ice crystals into this scene here, which is this guy kicking the soccer ball. It's not bad, right? It does a reasonable job of like interpreting the refractions. It does a reasonable job of like, we haven't given it any transparency information. It's just hallucinated the rest of the soccer player behind the ice, right? It's done a reasonable job of hallucinating where the glass is. Again, this is like a plausible combination of things. Using that same piece of ice and putting it into different scenes, it'll do things like, for example, like it will hallucinate lens flares. It will hallucinate complex refractions and reflections. So, for example, like on the right-hand side, it's tried to sort of like, I guess, reflect windows. And we haven't given it that cue. It's just sort of like inferred it from the scene. We can do things like we can drop light probes into scenes. So, for example, we've got this chrome ball that we've dropped into this scene, and it's made an attempt to sort of hallucinate what it thinks is behind the camera. Is it what was actually behind the camera? Absolutely not. But it's what thinks was there. It's a fascinating idea. And this one actually I quite like. So this one, what we're doing is that we want to put this glass into this scene. Again, if we just run it forwards, what it will do is that it does a reasonable job of like hallucinating the refractions. So there's some fairly complex light effects that are going on just where the stem meets the glass. You can see that it's completed the grapes back there. It does a reasonably good job of like making these things match, right? Like, it doesn't make any sense that this glass is floating in the middle of nowhere. Again, like I said, it's not sensical, but visually it's plausible. This one is actually a really good example of where we have something that is plausible but not sensical. So what we're going to do is that we're going to take this glass and we're going to put it underwater. It's from a physics point of view, this is nonsense. It's rubbish, right? But it's attempted to sort of reconcile the two. And I think that is kind of interesting, right? So it's tried to sort of reconcile the caustics, the complex lighting that's going on. It's very, very, very interesting. Again, sort of very similar example here where what we've done is that we've allowed it to sort of be a little bit more interpretive. So again, the same example, we've got this glass and what we want to do is that we want to put it in front of a fire. It's interesting that it's converted the glass into sort of like the water in there into ice, but it does a reasonably good job of hallucinating pretty complex refractions through the glass and, refractions through the I guess the water or the ice, whatever it thinks it's there. And that is just fascinating all on its own. Again, like I said, just an inherent property of the model rather than something that we've sort of induced it to do. So, there's a question that comes up often whenever I show this stuff is this physics, right? Have we built something that is able to sort of do some sort of like complex physics simulation for the world? Absolutely not. Right? No, absolutely not. Right. And I think that this make an interesting paper all on its own is examining how close it gets to sort of simulating ray tracing, how close it gets to sort of simulating very complex physical phenomena. But there's definitely something interesting going on. And it's something that we're going to be spending the research team is going to be spending the next few months sort of digging into. Hopefully we get a paper or two out of this, right? Because it's unique. And I think it's really sort of trying to see what are these models learned? Because again, coming back to their intuition around computer vision, they have this complex physical model of the world. What is actually going on? So, was this directable? Sure. Was it precise? Sure. Is it iterable? Nearly, right? We have it to a point now where if you nudge if you add an object into a scene and you nudge it a little bit, then the result won't change that much, but it still changes more than we'd like, right? So we're getting to a point now where we are getting pretty close to sort of our iterable target. And the workflow here is very, very, very simple, right? You take an object and you drop it into a picture and it gets integrated. There's no prompt. There was no magic here. It just kind of like this is just like asking it to sort of blend two images together, and it kind of just does it. And that was our goal, right? Is to make these tools really boring, right? And to make it like, the interaction itself just be very, very, very straightforward. So, our future is like, our future work that we want to do here is obviously we want to sort of make these results look better, right? You saw the visual results and they're okay, but I guarantee in a year's time, they're going to look very, very, very dated, right? And there's this idea of sort of like, and I mentioned it here as a technical term, but I'll explain it, right? What we want to do is that we want to have temporal and spatial coherence, right? So the spatial coherence was what I was talking about. The idea being that if you've got a small change in how you combine things together in terms of their position, you only want a small change in the output. But then we want to be able to extend this to video, which means that we want to make this work for video frames as well. So we want to be able to drop objects into videos. We want to be able to combine videos together. And for that to work, we need to stabilize the actual ML. So right now, if you try to run something on video frames, the video frames just change too much. And what happens is the results just, you end up with these popping artifacts, right? These things just sort of like, you see, like if you see a lot of these ML videos, you see that they've got like a lot of visual sizzle. They don't look good because they just change and they flow a lot. We want to be able to stabilize that. So a bunch of the research work that we're doing right now is trying to figure out ways of effectively stabilizing this so it works well for video. And that's definitely our next frontier. So, if we were to put all of this together, like, how does this practically work? Like, how does this turn up in somebody's life? I've got a very silly example here with moving a spoon. I could have gone with something a little bit more complicated, but I wanted to go with something that was relatively easy to visually read, right? So, and these are things that you can do like right now if you really wanted to, right? So, we've got tooling now that allows you to just select an object, right? So that's one of the things that we built. That's one of the a tool that one of the other teams built, right? So we've got this thing called Magic Grab. So we can grab that spoon and we could say, okay, we've identified this thing in a picture. That's a relatively new development, right? So you'll see this not just only in our editor, but most photo editors now that have an ML component will allow you to arbitrarily select an object. Then what we can do is that we can take that spoon and then we can pop it out so we can just arbitrarily move it. So what we've done is I'm sorry, that didn't look terribly good, but we're able to sort of take that spoon now and we're able to just, what it does is that it tries to erase it from the background. It's left a little bit of a shadow there. We're going to get a little bit better at that, but it's taken the spoon out. Now what we can do is that we can arbitrarily move this spoon around in the scene, but it doesn't look quite like it lives there yet, right? So what we can then do is that we can then use blend to basically put it back in and it hallucinates the shadow back for where it's supposed to be. And this sort of touches on our goal here. And we want to make, photos, images that you have arbitrarily designable, right? So the same way that you've got like a design that is made up of like tiny little design elements that you can move around, we want to be able to facilitate being able to do the same thing with photographs, right? So if you've got a photograph and there's a car on the wrong side of the street, you should be able to pick up that car and put it back on the other side of the street and have it reintegrate like it was there the whole time, right? So a lot of our research work now is focused on sort of like, I guess, sort of iterating towards that. And like I said, we can do it in small ways so far. Again, it could have gone with something a little bit more spicy here, but I hope it demonstrates the point. So I guess sort of the question sort of like coming towards sort of the end of this is, did we make AI boring again, right? Like, are we heading on a path towards making this tooling a little bit more straightforward, a little bit more accessible? Again, like I said, if we've done our job right, hopefully you won't even know that AI is in the process, right? We talk about AI as this big sort of exciting thing off to the side, but really it's just a tool, right, that we work with. And I think, again, closing thoughts around this is I think situating AI is important, right? Like really sort of like, again, like it's important to be excited about it. It's important to sort of understand that this is going to be a thing that is going to really like make huge changes to the way that digital creatives work, right? But more important than sort of like situating it is really understanding, like really sort of detaching it from the hype. we can be very, very, very excited by every press release that comes out, but really looking at it with a critical eye and thinking sort of, again, looking at that astonishing is not the same as good lens, and going, okay, right, here's this cool thing that you can do. How is this actually practically going to affect me as a digital creative? How is this going to change the way I work? How is this going to change the other way people work? How is this going to change the expectations of my clients when they come to me when I need to go and do a thing? And, largely speaking, this is up to us, right? As media professionals, as people who work in media, we get to help. Like, when we're not powerless in this conversation, and we get to sit, like, as users, as consumers of these tools, as people who build these tools, it's up to us to sort of set what the tone of this conversation is going to be. All right, folks. Thank you.